We're going to be looking at the chart for the disproportionality analysis between two drugs. So here, I'm going to open up the configuration panel, and you can see there's a brand name as the dimension and two choices. In my dimensions, I have a generic name available as well. In a real production system, I would also add active ingredients, for example. And here, where we only have Medra PT for the demo, we'd have all 5 hierarchies of Medra. But for the demo, we're going to just pick another product, cholesterol, since they have to be different products. There's a whole bunch of filtering capability here. These are all the filters where you can, everything's selected, but you can select partially. There's a filtering is a sort of a topic by itself. So there is another video on filtering. There's thresholds here, which says when SDR is generated. We'll go over those too. But for now, let's just start it up. So we get these the grid displayed, and it's locked, which means that the first column will be frozen. So we can scroll and freeze the first column and have our context of what the Medra PT is. If I were to unlock it, then I can actually move it as well. Let's keep it locked. Here you look at the AB, and you realize that A is the number of cases for carbon neutral product 1. And the Medra PT, and B, for example, is the number of cases for carbon neutral where this this PT was not listed as the adverse event. For C, it's the other product, cholesterol, number of cases where cholesterol is the product, and Medra PT, the PT is listed as acne conglobulata. D is number of cases for cholesterol where the reaction is anything but acne conglobulata. So once we have our A, B, C, and D, we can start calculating all the other values. So we calculate the PRR, we calculate the PRR, we calculate the sigma, the standard deviation, and the formulas are all listed here. All you have to do is click on a cell and you can see the formula, and basically see how it was derived. A couple of things to keep in mind. It says all calculations are performed using A, B, C, and D, and that's important to keep in mind. For example, here the formula says the PR was calculating by taking, or the PR upper bound for the PR, the 95% confidence interval upper bound, was calculated using PRR times raised to the E 1.96 times sigma. That is the formula exact, yes, but we did not take, when the calculation was performed, it did not take the existing PRR value. It recalculated PRR, because when PRR is calculated, or anything is calculated, we round up to 4 decimal places. And that's great for display, but when we're calculating and we want to use basically the most lower level input and calculate so that we don't lose any accuracy because of decimal places, because we were only up to 4 decimal places. So sigma was recalculated as well, PR was recalculated, and all this formula really had was A, B, C, and D. But this is a very good way of looking at the formula to realize how it builds upon the prior. You calculate PRR first, you calculate the sigma second, then you can calculate the 95% confidence level of upper and lower bound for the for this grid based on earlier calculations. But keep in mind that we do calculate from scratch, basically. The other thing is results are then rounded to 4 decimal places. This is not carved in stone. This was selected. So for the admin who's setting up ToroCube, they use a tool called ToroAdmin, another video on that. But they use ToroAdmin to decide what the precision is that they want to display, whether it's 3 decimal spaces, 4 decimal places, or 5. The other thing is we notice here that this was in red. And the reason this is red is if you look at our thresholds, we said that the p-value threshold for statistical significance is anything less than 0.05 or 5%, and this one is 2.6%, so, or 2.7 if I round it up, but that's the reason it's red. So it basically bears looking into. I can export this to Excel. This is my data panel, so I'm going to go to my data panel and export to Excel. And I'm going to open that file. So when I do that, all of these tooltips are also exported to Excel, so you can see what these columns mean. The formulas don't come through, right? I mean, you can't click here and get a formula pop up. That is that web page. But you do get any of the reds or anything that's highlighted in red. You do see that you see any notes will display a note, and the note will also carry over into Excel. The other thing is there's a sheet for filters. So this shows all the filters that are applied. So you give the context for what happened, what was used. Thresholds, again, what the thresholds were. So that's all there in this export. P-value, one of the things about the p-value is there's no formula for the p-value because it's a series of steps you take to determine the p-value, but we have the formula from an Excel perspective. So you can confirm this p-value by plugging into Excel with this formula and then seeing if the values match 2.6985, right? So we basically we do the right tail of the distribution curve and put the chi-square and degree of freedom of 1, and we get the p-value. So I'm going to take this, go to Excel, and then display getting 2.6985. So I'm going to go here, Control V. Yep, 2.6985. And the formula here is chi-square distribution of the right tail, 4.8918, and degree of freedom of 1. And 4.898 must have been our chi-square. So if we go here, this is the third one. Let's go to chi-square. Here, 4.8918. There we go. So this way we can validate all our calculations to know that, yeah, we understand how these numbers were derived, and where we can't do a simple calculation, we can use Excel to basically confirm the number. There's a note here for small, so we're going to generate a small sample size warning. So basically we think low sample size warning will be generated if A plus C is less than 120. So if I look at A and C, I'm just going to go crazy and use a large enough number that I'm bound to get a low sample size warning. I'm going to say 500. I think that ought to do it. Yeah, pretty much every row I'm getting a low sample size, small sample size warning. The other thing I can do is I can plot, well, let's talk about Yates correction first. So if I want to, I look at my sample size. I mean, this is artificially, I said that this is low, 500, by setting the threshold to 500. 500 by no means is a small number, but let's say I do have a small sample size, and so I want to basically adjust for that by applying Yates correction. I can do so. And then I can regenerate. And then when I go to my chi-square, it says chi-square Yates correction. If I look at the formula, there is this adjustment applied in the calculation to, for that's the Yates correction right there. So I can do that. Now, the other thing I can do besides the grid is I can look at a scatter chart for this. So I'm going to plot it, and the scatter chart is basically, it's plotting the PRR on the x-axis and the chi-square on the y-axis, and then these are, of course, this is capillary fragility, for example, and then it shows you what the PRR is, what the chi-square is, what the carbon neutral A is, and what cholesterol A is. And there's red lines here. These red lines are the thresholds. So if you were to look at, so right now, we're saying chi-square has to be greater than 4, and PR has to be greater than 2. So in this quadrant, that's when you want to worry. That's when you want to look at the, there's some sort of disproportionate reporting happening, and you want to take a look at why the numbers are the way they are. So let's see if we can move the thresholds to get something in here. So we know we can get, if we go to this 4 to 2 and maybe 1.2 for PRR, we should be okay. So I go here and say for PRR, I'll choose 1.2. So my threshold says that an SDR will be generated if PRR is greater than this number, and I've changed it to 1.2, and chi-square is greater than, I'll say 2, and I don't think I have to worry about A plus B plus C plus D is greater than 3. It is. The other condition where an SDR will be generated would be the lower bound of the 95% confidence interval, and the number of individual cases has to be greater than 3. So we'll stick with this, and this should work for us. by changing the threshold, we can basically see what we're getting and how things would change. So here now, this one is in the zone of concern, and we can look into it further. Now we just deliberately made it so that it would happen. The other thing these graphs do is basically, not that you need to here, but they do allow you to zoom in. So if I were to look at these two and I was really interested in them, I could just go like this, and now I've really zoomed them out. So this is really useful when things are crowded, when there's a bunch of points plotted seemingly together, and you can zoom out, or rather zoom in and sort of move them farther, and then really see them. And then what you can do is, besides zoom, you can also pan. So once you have something like this, you can actually go up or down or move sideways, whatever, and see where everything else is at. And when you want to reset things, just click on reset zoom, and we're back to where we were. So you can do that in the charts. The other thing we have here is we can have either a logarithmic y-axis or a logarithmic x-axis if we choose to do so. If you see a relationship and you kind of go, I don't think it's linear, you can try it out and see if it's a little different when you plot it logarithmically. You can see that now the scales have changed because it's not linear anymore, basically. Okay, so we can do that as well. In the data panel, I can also save the image of this chart, basically. So I can do that. And what I'll do is I'll get two files, basically. One is the image itself. Let's open that. And this is just the image that I had generated. So I can, I don't know, embed it in a PowerPoint presentation, send it to someone. And the other is the filters.txt file that just shows what filters were applied, so that if need be, a context can be provided for this image, like what went in to create it. From a data perspective, we also have a couple other options. There is a save report as. Saving reports, there's a video on saving reports, because saving and publishing reports is a sort of a large topic. So I've left that to another video because you can save a report for every chart, any chart. So there's a video for that. Export to ToroViewer has been disabled in this demo. And the reason for that is because we need to run it on a server, but ToroViewer is basically, you have ToroCube, you create a chart in ToroCube, and you want to share that with someone. You want them to be able to play with this and change the scale from logarithmic back to linear, or vice versa. You want them to be able to change the thresholds. And so when you export to ToroViewer, you get a web file that you can send to somebody, give it to somebody, that they can do the same interactivity and analysis. They're limited, of course, because it's not ToroCube, it's an export of ToroCube, it's a ToroViewer. What they do is they cannot change it, in the sense that you can come here and say, you know what, I don't want to plot it with carbon neutral, I want to plot it with infectagon. And you can. They can't do that. They are relegated to the product you chose. They are relegated to the MEDRA hierarchy you chose. So if you plot it against SOC, they can't turn around and plot it against against PT. But within the context of what you plotted, they can move things around. They can perform some analysis. So that's what would be the whole idea of the ToroViewer. And that pretty much is everything confirmation report, yes. At the end of this, when you would see, well, what cases went in, you can click on confirmation report and you'll get a list of all the cases. I'm not going to click it here because there'll be a lot of cases, and more importantly, it'll be very slow. And the reason it's slow is because this is running in demo mode, which means it's running on the client, and all the heavy lifting is done by the browser as opposed to the server, and it's going to be slow. In production environment, it'll be running on the server. There is, when you see the video for Toro admin, you will see that there's a way to run. The admin decides whether it's going to run on the server or a file is going to be generated and it's going to run on the client. So this is flexible enough that the admin controls whether you run it on the client, or it's a sort of a portable mode where there's no database at the back end. It uses the database to generate the files in one fell swoop. and then runs on the client. The ToroAdmin video would address that. That is it for the disproportionality analysis between two products. Thank you for watching.